let us solve this identified homogeneous equation. In our previous video, specifically for this specific equation, we have already provided proof that this is really a homogeneous equation. And now we are going to proceed with the solution. So if you're not yet convinced with this being homogeneous, please try to review the video pertaining on that. Here, we're going to use the process of substitution. Substitution in the sense that we are going to pick a certain, which of the two variables, x or y, will experience a certain substitution of variables. And this would be identified by either, if it's x, we're going to have vy, or y would be equal to vx. Okay? So now we are just going to pick which of the two we're going to substitute or use for substitution. But the hint there is discovering dx and dy, which of them here in our equation is paired with a simpler coefficient or expression, because that would be our basis in deciding which of the two variables will be used for substitution. Here, we know that dx is just paired with x, simpler than y minus 2x paired with dy. So we're going to pick this one here, and we're going to substitute vy for our x. Of course, if we're going to do that, as you go to our vy, as you take the first derivative of x, we're also going to take the first derivative of vy. So it's a product of v and y. So we're going to use the derivative of product. It's actually notated like this. So let me rewrite it here at the bottom. So the derivative of the product is, you can pick the first variable v and then derivative of the second, plus you pick the second and the derivative of the first. In short, that would be our substitution for dx as well. So now, going on our equation, you have x dx plus y minus 2x dy equal to 0. Simply substitute vy for x. Again, we chose this because dx is easier or with simpler expression. So our x would become vy dx. Oh no, the dx is also changed to its equivalent form here, this one. So you have v dy plus y dv. Okay? Plus, take note that in our second expression, you also have x. So you will have y minus, instead of 2x, you have 2vy dy equal to 0. The next thing here is to isolate the dy's and now dv's instead of dx, so that we could work on separation of variables as intended for this process. Supposedly, we are not going to disturb this because it's already in terms of dy, but let me just distribute everything else so that we could just easily look at the relationships of terms. This will be v squared y dy. As you multiply that here and here, you'll have v y squared dv. On the other side, you will have y dy and minus 2vy dy equal to 0. Okay? Now we just need to rearrange all the terms. We start with vy squared dv here, and then you will have v squared y dy, then a plus y dy minus 2vy dy equal to 0. Continuing here, where we factor dy, you will have v squared y dy plus, we have factored now dy, so that's actually simply plus y minus 2vy, that's dy equal to 0. The thing I need to remember here is we are going to use a separation of variables. Hence, we need to make sure that variables y and v would be able to be separated in terms of the process of our integration later on. So just simply, I forgot, there's still dv here. So we have v y squared dv. Here, I'm going to factor all the y so that y will be removed from that expression. Y v squared. I'm going to rearrange the terms, please pardon. I'm going to do it step by step. So you have v squared, factoring y you have 1, factoring y you have minus 2v dy here equal to 0. And then just simply rearranging them, you have vy squared dv plus y times v squared minus 2v plus 1 dy equal to 0. So from here, we are just going to make sure that we can separate variables. The point here is the variables to be paired with dy will only be y's, and for dv would be v's. So in short, we're going to multiply this whole expression by a certain expression where this will be removed from that. So we're going to multiply a rational expression. So once you do that, it will be cancelled here. Okay. And at the same time, also canceling y squared here because we only would like v there. So also y squared in this case. And of course, this is simply a rational expression. So multiplying that, again, this will be removed because of that. Okay. So we only have here v dv. But once you multiply this, it will appear here v squared minus 2v plus 1. And plus, again, this will be removed for this case. And then you will have y over y squared, or simply dy over y equal to 0. So we are now done with separating the variables. Take note, we only have y's here, and we only have v's on this side. This time we are now going to integrate both sides. You have integral of v dv over v squared minus 2v plus 1. And you will have here the integral of dy over y and the integral of 0. Since v is complicated, then we're going to use here another substitution. So let me just pause for a while here. Let me also share here a certain process to allow us to integrate this without any problem. Of course, we know that our denominator can be represented by, or can be written as the square of v minus 1 because it's a perfect square trinomial. So once we try to look into this, if we're going to let a certain u be equal to our denominator v minus 1, okay, and then du will become, of course, the derivative of that is simply just equal to dv. Okay? We can rewrite this entire expression into this form. You have the integral of your v. Take note, your v as well here will become u plus 1. Okay? Because as you manipulate that, u plus 1. So you will have an expression similar to this. You will have, instead of v, you will have u plus 1. And then your dv is du over the square of u. Okay? So we're doing this because we would like to really represent this in another process. You can separate this into two forms. The derivative of u over u squared du, of course, plus the derivative of 1 du over u squared here as well. Okay? And then we can have here a simple expression. Again, let me stop here in the meantime. Let me rewrite it here. I didn't expect that I don't have much space. I might be using another page here. So you will have here the u over du is just du over u, and then plus you will have the integral of the u power of negative 2 du here. Okay, as this is u to negative 2. So the integral of both would be equal to the natural logarithm of u, and then you will have here equal to no, the other one is plus. The integral of this is equal to u to the power of negative 1 over negative 1. Okay? Or this is entirely equal to the natural logarithm of u, then plus 1 over u. And take note, what was u earlier? U is v minus 1 as we return to v because this is what we are trying to solve. So we have here the natural logarithm of our u, which is v minus 1 plus 1 over v minus 1. Okay? Or plus c. But let's just pause c in the meantime because we will be using this here. That's the result for this entire expression, the first term here. Because the second expression is just easy to look at. So okay, I'm going to use another what do you call this one? Another page. But let me copy this because this is what we want. Okay, that one here, copy. Okay, here, let me paste that. Paste. Okay, this was our equation earlier, and then of course erase some of these things here. This one, let me erase that. This is what we're trying to solve, but take note of all the things that we use as well. When we return here, this was the result for that, the first expression. So let me copy this as well. Okay, copy, return to the other side, paste. This was actually the result for this one here. So the first term, v over the v squared minus 2v plus 1. Okay, that's just that. Okay. At the same time, I also need to remind ourselves that we represented v earlier in this manner, so that we could really look into that. This is our v earlier. Let me copy this as well. Okay, so that we will return to really the correct answer later. Let me paste it here. Sorry, I wasn't able to do that. Let me return to this. Okay, copy, and then return here, paste. Okay, this was our expression earlier. So simply just erasing the rest of the items here. Sorry for that. Erase this one here, just like that. Okay, so let's just continue to our form, as this is only the result of this first, and then you will have, of course, the result of the second, dy over y, which is simply, oh sorry, that's y, which is simply the natural logarithm of y. Okay, natural logarithm of plus c. So completing this, you will have the forms, the natural logarithm, this first result, of v minus 1 plus 1 over v minus 1 plus the natural logarithm of y, okay, is equal to the, equal to the integral of 0 is a certain constant c. So as mentioned earlier, there should be some c here, some c here as well, but since we are representing c in general, it will all be moved on this side and added to that, so let's just simply not write it like that. So here, this is now our form after we integrate our form like this after separation of variables. But make sure that we return to our original form here of x. We're talking about the value of v, or the representation of v, from here. So we can say that v is equal to x over y. So v is equal to x over y. So you will have here natural logarithm of x over y minus 1 plus, plus 1 over x over y minus 1 plus the natural logarithm of y is equal to c. So simply manipulate this because we don't like to see something like that. You can also do it like here. So you can you can simply apply here a certain process. So you can combine like this. You will have LCD of y, so x minus y here, plus here as well. So this is on nested rational expressions. You have x minus y over y plus the natural logarithm of y is equal to c. Using the properties of logarithm here, we have the logarithm of the absolute value of the quotient. So we can apply it something like this. The natural logarithm of your first x minus y minus the natural logarithm of y. Okay, so that's a property of logarithms. Here, you have nested rational expressions as mentioned earlier. This is equal plus y over x minus y, as you will have here keep change flip method, plus the natural logarithm of y is equal to c. We have this, we have that, so that will be cancelled. So you will have here natural logarithm of x minus y plus y over x minus y plus, no longer plus, because this will be removed, is equal to c. Just to remove that, you can multiply all terms here with x minus y, or the binomial expression. In short, your final answer here is x minus y times the natural logarithm of x minus y, and we cannot really multiply them because this is a natural logarithm. Then plus simply y, because this will be removed, equal to c times x minus y. This is now the solution of the intended item on the previous page. We're going to return to that because you can also, if you would like to read it to have some y here, you can isolate this, but since we also have y there, so that's already okay. So we use here double substitutions, but of course we started with the homogeneous equation, and we applied the necessary scales and operations. We even reintroduced here the laws of logarithms or properties of logarithms, nested rational expressions. So please try to review those materials. So this is the answer now to the question of our previous page. This one here. This is a solution of that using this process. Thank you very much for watching.